Hi everybody and welcome. Today we're going to be talking about the graphs of quadratic functions and some of the properties of those graphs. So after watching this video, you should be able to identify the key features of graphs of quadratics, including the vertex, axis of symmetry, and whether or not it opens up or down. So a good example of this, I like to think of Steph Curry shooting before basketball games. You'll see that he does some pretty crazy things, and in this example, he's shooting it over the top of the backboard, basically shooting it from behind the hoop. So in order to do this, the ball needs to go very high in the air, and if you think about it, that is going to be a good quadratic motion graph. It's going to go, again, up and then down using that parabola shape. So that's one example of a parabola in real life. Important to know the properties of that because Steph Curry needs to know the properties of his shot before he shoots it. Right? It needs to go very high. It can't be a low arcing shot. So one practical application of analyzing Steph Curry's shot to lead us into our example for today. So taking a look here to start off, we are first going to define our key terms. So one thing that we're going to look at today, a new vocab word for us, is axis of symmetry. And this is basically just the vertical line that divides the parabola into two parts, and specifically two equal parts. So if you are drawing your parabola, and we'll do it in blue here, and let's say it is somewhere on the bottom like this. Well, our axis of symmetry here, I don't know why that got super big, would cut it directly in half. So we'll go straight down the center and cut it directly in half. So that's going to be important. The way that we can solve for this is our x-coordinate is equal to negative b over 2a. And again, using that same ax squared plus bx plus c formula that we were using over the last few days. So we put a on the bottom, put a negative b on the top. That's going to give us the x-coordinate, and we can plug that back in to find y. All right, so graphing these equations, if you have a graphing calculator, you can pop this in. You will be expected to be able to do this by hand as well. So you just basically make a chart of values here. Let's try a few different ones here, maybe like, we'll start at -3, -2, -1, 0, 1, see what that gets us. So you plug in the value into the equation that I circled up top there, so it'd be like -3 squared plus 2 times -3, all minus 1. And when you do this, you'll be able to get that output answer that you're looking for. So that first one is 2. The next one here gets us -1. Our next one here gets us -2, -1, and finally +1. So I did all the work for these beforehand, but you would do the same thing here in terms of plugging it into your equation. Once you do that, you have your table of values. You can start graphing them. So x is to the left or right, y is up and down. So we go 3 to the left and 2 up. Next, we go 2 to the left and 1 down, 1 to the left and 2 down, and then over 0, down 1, and then to the right 1, up 2. So there is our parabola. And then next we would be able to kind of cut this down the center here. And when we do that, we'll have the left and the right side. So again, we cut that in half there exactly at the green axis of symmetry. That is a vertical line there, not a horizontal line. I was almost saying that. So x equals -1 because it's 1 to the left. And we can check this, and we'll do that for our next question. So see if what we did was correct. And then finally, vertex here. We know that x equals -1, so we would plug that back in and see that the vertex comes when y equals -2. And that's at our minimum point. And finally, this graph opens up. It's a smiley face. It goes upwards. So let's see. Plugging this back in, taking a look at some of our examples here, some real problems where we would apply this. If our first term is positive, it opens up. Next, a vertex, we use that same formula. So the x term of the vertex is -b over 2a. Well, a equals 1, b equals 2. So again, 1 and 2. Plug those in, we would get -2 on top over 2 times 1 or 2 on the bottom, or just -1. And then now we would need to plug that back into our equation. So -1 squared plus 2 times -1 minus 1. And that'll get us that final answer of -2. So that would be our vertex. The coordinates of the vertex are -1, -2. Finally, axis of symmetry, we just take that same x value, and that's the axis of symmetry. And that's what we're looking for. So again, your job here is to do the exact same thing. See, does it open up or down? We have a negative first term, so that tells you that we go. You fill in that blank. Next, for our vertex, do the same thing. Negative b over 2a. Well, let's identify a and b from our equation over here. And then finally, the axis of symmetry is, again, it's just a repeat of the x value of the vertex. All right, so a second thing, we've been talking a lot about a vertex, but let's make sure that we're all on the same page in terms of what it means. So a vertex is, this is the min or max value of a quadratic. So if we're looking at this here, vertex is on the bottom. That is a min, that's a vertex. If it's on the top, that is a max, also a vertex. And again, the coordinates for the vertex, we have x equals negative b over 2a. Or an additional way to look at this is they have something called the vertex form. I'll make a little box for it. This is like a new y equals mx plus b. So if you ever see an equation in this format, the vertex here is the number inside of the parentheses and the number on the outside, so the h and the k. So you don't actually have to do any calculating for that. They just give it to you. So again, important to remember, though, that that's a negative h there. So as long as you keep that straight, you'll be good to go. So a second way to see it. So again, important to have that vertex equation written down in your notes because that's going to help your life quite a bit. All right. So opens up or down, first term, again, seeing this as positive, so we're going to open up. The vertex, we know that that is h comma k. Well, this time we see k on the outside is negative 2, and on the inside is the opposite. So it's going to be negative 1. And then axis of symmetry, we just take that x value and bring that straight down. So these equations are actually nice in that vertex form because not a lot of calculating to do. The last thing, this is an extension activity for today. If you're familiar with completing the square, basically a very similar format to solving here. So you have y equals x squared plus 2x, and you also have a negative 7. What we're trying to do is get this into that y equals, gosh, it just closed out on me. We're trying to get it into that y equals a times, x minus h all squared plus k form. So that's our goal for vertex 1. And once we do that, what we're going to be able to see here, again, taking a look, is we're going to be able to see the h and the k to find our vertex. So we need to find a square for x squared and 2x. And the way that we do that is we can actually add 1 to this and kind of block it off. And if we add 1, we have to also subtract 1 to keep it balanced. So if we put 1 in on the left, we got to take it out to make sure that we're not adding or subtracting anything. We're just a net zero balance there. When we do that, we're going to be able to factor this into x plus 1 times x plus 1. On the outside, we have negative 8. So now we just have our x plus 1 squared minus 8. So we see that our k value is here and our negative h value is here. So our vertex is negative 1, comma, negative 8. And again, if you had a solid algebra 1 background, you'll have completing the square down as something that you've seen before. If you haven't seen it yet, that's totally fine. This is more an extension. It's not something that we're necessarily going to be assessed on, but just something to see that you can go back and forth between the two using a skill from the past. All right, as always, any questions, feel free to reach out with, again, Teams message, remind message, email, any of those things, set up an appointment. We are here to help, but please make sure that you finish up those remaining questions that were not solved in the video and the notes. Take a picture of them and submit them to me. I will see you all in Teams very soon. I appreciate you.